This tool has been developed to reduce the cost and complexity of testing the inrush current of a supply. It is also useful for debugging problems server OEMs and power supply design engineers often face in the field when their power supply was validated using ordinary programmable AC sources. Typical server supplies operate over a wide range of input AC voltages, from 90 to 264 volts ACs, with output power ratings from a few hundred watts to several kilowatts. To provide a smooth initial transition into the operating state or a restart of the supply after a power outage, they are provided with an inrush current limiting network. This network incorporates a current limiting resistor that gets shorted by a mechanical relay when the bulk capacitor voltage reaches a predetermined level close to the AC voltage level. During comparatively short AC line dropouts or in extended holdup time applications, the relay contacts shorting the current limiting resistor remain closed. If the AC line recovers at a phase angle close to 90 or 270 degrees, and the peak AC voltage exceeds the bulk cap voltage level, a recovery current surge known as rerush occurs. This can cause an overstress condition of the components on the primary side, leading to an early failure of the power supply. Testing inrush or rerush immunity with multi-kilowatt programmable AC sources makes the test setup bulky and expensive. Also, using a conventional programmable AC source with inrush current capacity limited to only a few tens of amps can result in erroneously passed rerush tests during the development stages. Power supplies not tested properly for inrush and rerush can have a high failure rate in the field when exposed to very low impedance AC mains. This tool supports up to 5 kilowatts of continuous power. It contains advanced circuitry capable of starting or restarting the AC voltage at 0, 90, 270, or 360 degree phase angles. It was designed to operate with extremely low AC mains impedance sources and can withstand over 1,000 amps of peak surge current. The tool can also be used with buffer caps to enhance the peak surge capability of programmable AC sources. There are two control options, either using a LabVIEW-based graphical user interface or an external equipment set consisting of an oscilloscope and function generator. The LabVIEW operation is fully autonomous and displays unit under test voltage and current waveforms on the screen without the need for any additional equipment. Connection to the tool for LabVIEW control is done using a standard USB port and cable. The tool has a power cable that connects it to the AC mains. It provides power to the unit under test through a standard AC outlet located on the tool itself. The power can be turned on and off for any programmed amount of time and recovered at a specified phase angle using the LabVIEW user interface. The tool has 3 BNC connectors for operation using external equipment, one for control, one for monitoring AC input voltage, and one for monitoring AC input current. All 3 of the BNC connectors are fully isolated, so no additional special equipment or isolation probes are needed. The green LED indicator on the tool shows the presence of AC power to the unit under test. The LED will also blink coincident with application of an AC transient. This shows the tool in a basic hardware setup. The power cord for the tool is connected directly to the AC mains. The input of the supply under test plugs into the controlled AC outlet on the tool. Output of the power supply is connected to an electronic load. A computer running a LabVIEW program controls the tool via a standard USB cable. This will be a real-time demonstration of the LabVIEW program controlling the tool with a power supply connected to it. We first begin by selecting the mode of operation, either inrush or rerush. Selecting inrush initially turns off the AC in preparation for a burst of AC cycles. Rerush initially turns on the AC in preparation for a drop of AC cycles. The next consideration is the number of cycles for the AC line event. This is set using the duration cycles control on the screen. Next is the repetition minutes controls that sets the interval time between events. Critical to obtaining a worst case current level is the phase angle, which is set using the angle control. Typically, the 90-degree selection gives the highest inrush current level. The number of tests to run control is used to program for single or multiple events. The fire event control activates the event. Let's go ahead and run a test. First, we'll select Inrush operation. Next, the duration control is set to 100 cycles. Then the repetition control is set to 0.1 minutes. The angle control is set to 0 degrees, and the number of tests to run is set to 1 for a single event. And then we will press the fire event control. Voltage and current waveforms are now displayed on the screen. Using the analysis function allows us to zoom in on the inrush current spike. This is a typical current waveform showing charging of the power supply bulk capacitors. This time I'll repeat the test using the rerush mode. First, set the duration control to 5 cycles. Leave the repetition control at 0.1 minutes. Set angle control to 90 degrees. Then press the fire event control. Waveforms showing a unit under test voltage and current will be displayed on the screen for the last test done.